Today we will learn about Haworth projection. In previous sessions we have seen what is Fisher's projection and we have drawn the different structures. Now let us see what is Haworth projection. Haworth projection is nothing but to represent structures in a cyclic way. Okay, the representation of cyclic structures is known as Haworth projection. So this is generally used in organic chemistry as well as in biochemistry. So today let us see how we are going to imply this Haworth projection to our monosaccharides. Now before going to Haworth projection, today let us see what is Hemiacetals and Hemiketals formed and why this formation is important for the Haworth projection. Now let us see the reaction of Hemiacetals and Hemiketals. Now here this is the reaction what I have shown you very clearly about Hemiacetals and Hemiketals. Now the aldehyde, it is reacting with an alcohol molecule to form a hemiacetal. This OH, for the clear understanding, I have used two different colors such that the black color represents the alcohol group. Now this is the aldehyde, that means nothing but aldoses, now reacts with the alcohol and forms hemiacetal. Now the hydroxyl group is added here and to this oxygen the R group is added here. So this is hemiacetal formation. Now this hemiacetal, similarly this is seen with the ketones, that is ketosis. This is the ketone group. Okay, so now this is reacting with an alcohol and results in the formation of hemiketal. So when an alcohol reacts with the aldehyde, it is forming hemiacetal. When it is reacting with a ketone, it is forming a hemiketals. I hope it is clear. Now let us see how the Haworth projection is related to this hemiketal formations. Now let us see the next, let us go forward for the next step. Now here I have shown you the hemiacetal formation. Now here the alcohol group, this should be removed. Now what happens is, if you take the structure of, let us take the example that is glucose. Here now let us draw the structure of glucose. That is 1, 2, 3. It is a 6-membered compound. So let us draw 6 carbons. 1, 2, 3, 4, 5, 6. The first carbon should be functional group. The last carbon is alcohol group. And as glucose, hydroxyl group will be on third carbon, hydroxyl group will be left side. Okay. Now let us complete the structure. This is the structure of glucose. Okay, this is the structure of glucose. This can be written even in this way. Now this I am showing to relation to this. Now let us see this molecule, that is this one, is this. Okay, and the entire chain I am considering it as R. Okay, and to this carbon we have one more alcohol group representing here. This is the structure which I have shown very clearly here. Now what happens is, the fifth carbon hydroxyl group, okay, this hydrogen reacts with this alcohol and results in the formation of now what happens is, now here ROH is removed, that is OR here, and this hydrogen, it is removed in the form of ROH. Now what happens is, the remaining one We are left with only oxygen here. So this is the ring structure of glucose. Ring structure of glucose. Okay. Now this ring structure is helpful for us to put a Haworth projection. So I hope you all are clear with this. I'll repeat once again. So this is the aldehyde reacting with alcohol, and here this is a reversible reaction where what happens, the alcohol group, okay, this is added here at this position and alcohol group is added here. Okay, next R group. Now this hemiacetal structure is nothing but this. This is hemiacetal structure. Hemiacetal structure. Now when the fifth carbon is reacting with this to remove the alcohol, it is forming a ring structure. Now let us see about the Haworth projection. So as it is a six-membered compound, we generally prefer pyranose structure. So in Haworth projection, two kinds are there. That is for six-membered. Okay, for six-membered compounds, five-membered compounds. For six-membered compound, it forms pyranes. Structure pyranes. For six-membered compounds, it forms furans. So the pyranes we pronounce generally as pyranose. We say it as pyranes or pyranose. Furanose. Okay. So the structure of furanose will be like this, and structure of pyranose will be like this. Okay, so in Haworth projections, two kinds of presentations will be there depending upon the number of carbons. Six-membered carbon compounds will give us a pyrene structure. Five-membered compound will give us a furan structure, and that we are calling it as furanose, which appears like this, and this is pyranose, which appears like this. Now let us see how this glucose structure will put in the form of pyranose. As it is a six-membered carbon, so it will give us this structure. Okay. See. Now let us start the numbering. This is 1, 1, 2, 3, 4, 5 and 6. So same thing we'll put here also. 1, 2, 3, 4, 5. Okay. Now here, according to this structure, the first carbon is connected to fifth carbon. This is the first carbon. It is connected to sixth carbon through an oxygen bridge. So this is the oxygen and here the oxygen. So first carbon is connected to fifth carbon through oxygen bridge. First carbon is connected to fifth carbon through an oxygen bridge. And fifth carbon is connected to sixth carbon. That means here, like this. Okay. Now, the first carbon. And what are here, the one common thing what we need to observe is, here in the ring structure, which is inside the ring structure will be outside, and which is outside the ring structure will be inside. Okay. Now see, this is towards the ring, or in a simple way, the groups which are present towards the ring will be outside, and opposite to the ring will be inside. So first carbon, so hydroxyl group, it's towards the ring, so it is outside, and here hydroxyl group is opposite to the ring structure, so it is inside. So this is the Haworth projection of glucose. We call it as glucopyranose. So this is Haworth projection. I'll tell you once again this one. The first carbon is connected to the fifth carbon. Now this fifth carbon is connected to sixth carbon. The groups which are present towards the ring will be outside, and the hydroxyl group which is outside the group, that means opposite to the group, okay, opposite to the ring structure, that will be inside the ring. Okay, so this is about Haworth projection.